Hello. In this demonstration, we're going to see how to conduct an ANOVA test with SPSS. Specifically here, we're going to be doing a one-way ANOVA test in the sense that the difference between the samples is defined by a difference in one variable. And the examples we're going to use here, they are the oversimplified examples from chapter 11.3 in the Stevens' Introduction to Statistics, the Think and Do book. And we have two cases. In the first case, the three samples have similar means. In the second case, the three samples have disparate means. And these were nice small samples, and the reason this was done in the book was so that we could actually do the calculations by hand. And even with these small samples, it's hard to do by hand. So, well, it's a good thing we're learning to do it with SPSS. But when we did do it by hand, we found the variance between groups and the variance within groups, took the ratio, and got an F test statistic for the case 1, which was 2.73, which led to a p-value of 0.106. That was too big. We failed to reject the null hypothesis, and there is not enough evidence to conclude that the population means are not equal. In the second case, we did the same process. We got an F test statistic much bigger, p-value much smaller. We were able to reject the null hypothesis. In this case, there is sufficient evidence to conclude that the population means are not equal. All right? So in this case, the sample means are not different enough. In this case, the sample differences are different enough. The difference in sample means. Okay, so let's see how we do this with SPSS. The first thing to observe is that we can't really put the data in like this into SPSS in this 3-column format. We have to do it in standard format where each row is a case and each column is a variable. So each one of these, right? So what we have here are 15 cases. Each case has a sample description and the actual score, right? So that's what we have here. So we have 1, 2, 3, 4, 5 from sample 1, and these are the scores. 5 come from sample 2, these are their scores, right? So each row is a case. And you do that for both situations with similar means, disparate means. So we'll let SPSS do the work for us. Let's work with the similar means first. Open that up. So there's the data. And it's worth pointing out when you go to variable view, while the sample is a numerical value of 1, 2, 3, it's really just the name for the sample, and it would be maybe the name of the treatment, fertilizer, no fertilizer, organic fertilizer, something like that. But here they're just numbered, but they're really not numbers. They're numbers, they're nominal. They're just names, and so you want this variable, the variable that distinguishes the different samples, to be a nominal variable, right? And then the actual score will be scale, right? Very important. Once you have that, then you just go to Analyze, Compare Means, One-Way ANOVA. And the dependent list, that's what you're checking for the difference in. We're checking for the difference in scores, mean scores. And the factor in this case is just the sample number. And remember, this one needs to be nominal. What I'm going to do, I'm going to go up to options here because there's a couple options that are worth putting in there. I'm going to get a table of descriptive statistics and a means plot. Click Continue, click OK, go to the output window, and here's that table of descriptive statistics. You can see for sample 1, the mean was 4, sample 2, the mean was 5, sample 3, the mean was 6. Right. So they're pretty similar means. And when you look at the ANOVA output, what we call it in the book the variance between groups and variance within groups, they call the mean square between and within. And when you take the ratio, you get an F test statistic 2.727, just like we did by hand. Significance of 0.106. Failed to reject the null hypothesis. And we can't conclude that the population means are different. And while this graph is a little misleading because it doesn't start at 0, you can see that the mean for sample 1 is 4 mean for sample 2 is 5, mean for sample 3 is 6. It looks like a lot because they started at 4, but it really isn't that big. In fact, it's not significant. If, on the other hand, we go to our data, the other data set with the disparate means, run through the same process, analyze, compare means, one-way ANOVA, the sample is the factor, the score is the dependent list. We'll do the same thing with the descriptive statistics and a means plot. Click OK. Go to the output. And here you can sort of see what happened. Sample 1 still had a mean of 4. Sample 2 has a mean of 5. Now sample 3 has a mean of 10. So that's what made the big difference here, right? You go to the ANOVA output table. There's the variance between groups, within groups. You get an F test statistic of 28.182. As far as an F statistic goes, that's pretty big. It leads to a very small significance, or a very small p-value, certainly smaller than any significance level. And then you would reject the null and say, yes, the population means are different. And then the plot sort of demonstrates that difference, right? 4 up a little to 5, and then way up to 10. So that sort of helps get a little visual on how the comparison looks. And it's a lot easier with software. Anything beyond small number of samples of small equal sizes, you really need software, and so we're going to let SPSS do it. That concludes the demonstration. Thanks. Bye.